Good evening, learners. So, is the screen visible and am I audible? Okay, we'll be starting within 1 minute. So, welcome everyone to the NPTEL course on post-harvest operations and processing of fruits, vegetables, spices, and plantation crop products. So, this course is instructed by Professor H.N. Mishra sir, who is a professor in the Department of Agriculture and Food Engineering, IIT Kharagpur, and I am Shikha Sharma. I am a research scholar in the Department of Chemical Engineering, IIT Guwahati, and I am the TA of this course for this July 2026 semester. So this live interaction session is for week 4, and the assignment deadline for week 4 is 19th. Please submit your assignment on time, all the assignments. So topics that we will be discussing today will be mostly regarding the module 4, which includes lecture 16 to lecture 20. So it is about cleaning and washing, and then sorting and grading, then peeling, pouring, and slicing. Then it contains about the containers and the packaging materials for fresh produce. And lecture 20 is about packaging methods and equipments. So this 5 lecture videos I hope you have all gone through Professor Mishra's lectures. So uh, now we can, in today's class, we can discuss some of the theoretical questions, as well as we will be discussing some of the numerical based questions in this tutorial class. I hope this all these assignment, all these modules or all these interaction sessions, live interaction sessions, they are helping you to solve the assignments for the respective weeks. And if you have any doubt, please feel free to ask either in this live interaction session, or you can ask in Q&A discussion forum. We'll be happy to answer all your queries. So, okay, let's begin with today's live interaction session. So this is the question 1 for today. So this is about this question is regarding basically the cleaning methods. So the cleaning methods, basically it includes 3 cleaning methods. So we have this different fruits and vegetables. When we harvest it from the field, it will be these fruits and vegetables. They are mostly in the like they will be mostly with the other foreign materials like sand, also some kind of insects may be there, or some other weeds or other plants along with it will come while we are harvesting any fruits and vegetables, or even the stem or leaf part of the same plant or same fruit plant or any vegetable plant can also come. So because of that, we need to do cleaning first. After harvesting, we'll do cleaning of the fruits and vegetable. Then we will be all the uh, farmers, and they will send or transport it to the different industries, where in industry also, when fruits and vegetables are received, they are first clean, washed properly, and then further processed into different products or then the packaging or the then different kind of package. The raw fruits also can or vegetables can also be sent for the packaging like vacuum packaging or any like in carrots or then further sent to the for the selling purpose. Sometimes the fruits and vegetables they are being processed and then like into the jam or different products, juices, and they will be packaged and then sent to the customer. So first step is the cleaning of the fruits and vegetables after harvesting. So these cleaning methods, there are different cleaning methods of fruits and vegetables. So it includes like dry cleaning, where the air or the dry brushes or the clothes are used for the cleaning of fruits and vegetables. Then trimming. So trimming is basically used to remove the unwanted leaves or the stem or the roots prior to their packaging and storage. Then next is the wet cleaning is done, which is also known as washing. So it is done uh, like the produce is basically being washed with the clean water, usually by putting in a water tank having a continuous flow of water and agitation. So these wet cleaning or washing, it has further like different methods of doing it, like either soaking, water sprayers can be used for washing purpose, then rotating drums can be used. Then rotating brushes can be used, and last is the vibrates washers can be used for cleaning for cleaning or for wet cleaning methods of the fruits and vegetables. So here in this question, this assertion is talking about the soaking method. So the soaking method, which is under wet cleaning or washing method, it comes where basically the water is being used for cleaning of the fruits and vegetables. So this soaking is often used as a pre-cleaning step in fruits and vegetables processing. So this is the assertion. Yeah, so the assertion basically is talking about that the soaking is often used as a pre-cleaning method or the pre-cleaning step in fruits and vegetables processing. Reason is that soaking in flowing water or liquid is effective in only removing surface dust or impurities. So it is saying that one is that the soaking method, which is used as a pre-cleaning step in fruits and vegetables processing, and then another is reason is saying that the soaking, because we are doing soaking, so soaking only removes the surface dust and the impurities, and it will not do the internal cleaning. So we need to tell if the assertion is true or the reason is true, and if assertion is is correctly explained by the reason or not. Okay, so let's see the answer. So the answer is saying that basically A is correct, where it is saying that both the assertion and the reason they are true, and reason is the correct explanation of the assertion. So this is the like the pictorial representation where it is telling that how we are doing the soaking process. So soaking is usually done by putting the fruits and vegetables in the water for some time, and sometimes we can use like some maybe the chemicals or maybe like the baking soda or something just to clean these fruits and the surface of these fruits and vegetables. And sometimes we use maybe lukewarm water to clean the fruits and vegetables. And sometimes we can also do like the agitation process also to clean fruits and vegetables. So yeah, so soaking basically it is a pre-cleaning step which is correct. Like what we do is when we are even buying the fruits and vegetables from the market, we first go for its washing, which includes sometimes we put the fruits and vegetables into some bowl and then we put some water and we'll soak these fruits and vegetables for some time so that the surface of these fruits and vegetables can be cleaned. So yeah, so soaking is basically in soaking, flowing water or other liquids basically are used for soaking of the commodities. And the soaking is primarily used to loosen surface contaminants and is not suitable for deep cleaning process. So hence it serves as a pre-cleaning method or preliminary method, and this function is directly due to its effectiveness in removing only the surface level dust or dirt. So it will not do the deep cleaning, it will do the surface cleaning only. So soaking can be done using several different methods, like soaking into the normal water. Then soaking can be done like in the lukewarm water or little warm water, suppose 50 degrees Celsius water. And soaking can be done with the chemical assisted soaking can be done like with the addition of some detergents or 1.5% HCl solutions can be used for soaking. And then sometimes the soaking water basically are also like when we are doing the soaking, it can be usually removing the traces of some pesticides, sometimes insects and the fungicides also. Then baking soda sometimes can also be used for like can be used or can be added in the soaking water so that the cleaning of fruits and vegetables can be done properly. Uh, Sometimes we use like in home we don't use HCl. Sometimes what we do is in at the home level citric acid. So that we squeeze one lemon, half of the lemon into the water, soaking water, or when we are soaking fruits and vegetables, so that the chemicals which or the preservatives can be or the pesticides can be removed from the surface of these fruits and vegetables. Then agitation can be done where the produce is immersed in some water. Then afterwards, then the mechanical agitation can be done. So mechanically agitation is basically is done. Some RPM we can provide in the soaking water so that it will be easy uh, to remove some strongly adhered strongly adhered dirt on the surface of the food product. So next is the effectiveness of the soaking. It basically depends on the temperature of the water, which temperature, like what temperature we are using for the water, and then soaking time, how much time we are soaking our fruits and vegetables into the water, then RPM or the agitation, then nature and amount of the soil which is adhered to the surface of the fruits and vegetables, then type of the produce, which type of food produce it is there, like the shape maybe of the fruits and vegetables, like sorry. So the shape of the fruits and vegetables also affects like maybe like if it's round or it is like little cylindrical shape or like which like what is a leafy vegetables, the surface area is very high for this leaf part. So in the spinach, like in spinach, so which shape of the food product it is there, like the fruits for the fruits and vegetable, it basically depends on this produce also. Then the concentration and the type of cleaning agent we are using. So sometimes like we are using some cleaning agents like the mild acids we are using or baking soda we are using. So their concentration and which type of cleaning agent we are using, it is also uh, determining how much effective the soaking process will going to be. So basically here in this question, assertion is true that soaking is basically a pre-cleaning step for cleaning of the fruits and vegetables. And also the reason is true, which is saying that this is done for removing the surface dust or the impurities, but not for the deep cleaning purposes. So, and reason is true, correctly explaining the assertion process that because the surface dust is being removed in the soaking process. That's why soaking is basically considered as one of the important pre-cleaning steps. So here assertion and the reason are true and reason correctly explains the assertion. Okay, let's discuss this next question. This question is basically related to the cleaning of spices and the condiments. So the in the spices and then condiments, basically there are different impurities present in them. So those impurities may include like sand, stones, dust, nails, baling wires, and pieces of jutes, cotton threads, nuts, bolts, pieces of charcoal, toys, rodents, dropping, and dead and live insects may be present in these spices and condiments. So they must be cleaned before uh, further processing. So there are different equipments can be used for cleaning of these spices and the condiments. Uh, so like we can use basically the magnetic separator, sifters, air tables, destoners, air separators, indented separators, and then spiral gravity separators for cleaning them. And this is basically the sifter, looks like this. So this question is basically regarding the sifter only. So which of the following statements is correct regarding use of the sifters in food processing? So we have four statements. Sifters remove basically particles of the wrong size using a set of vibrating screens. Second statement is saying that the efficiency of the sifter depends on the uniformity of the product shape and size. Then third statement says that sifting is always 100% efficient regardless of the product shape. And fourth is saying that non-uniformly shaped products reduces the effectiveness of the sifting operation. So we need to tell which statement is correct here. Okay, so let's see the answer. So statement 1, 2, and 4 are correct here as per the answer. So this is basically the sifter. In the sifter, what happens basically here, it is the feed or the inlet will be going inside the this sifter. This is basically the dust-proof cover at the top, and then there are different sieves here of different mesh size. So this is a screen frame and sieves are there. Then this here the sieving operation will take place. The uh, particle size which is greater than to the mesh size, it will be at the top of the screen. Like here at the top will be larger particles and the smaller particles will pass through the this mesh size and they will come down. So the larger particles will be then collected here as an outlet, and then smaller particles here, they will be collected from here. So like this, and here is the vibrating motor. So this sieving process will always be vibrating because of the motor. So because of the vibration, this like continuous vibration, like so, like this vibration will be there. So the particles can be sieved easily and little faster. So larger particles will be like this. Smaller particles will come from the bottom of the sieve. So sifter, it is basically separating based on the size and the shape. So basically sifters remove particles of the wrong size from the product via a set of vibrating screens. So there will be vibrating screens, and there can be multiple vibrating screens, one above in series, like one above another. So the larger particles will be here, then smaller, then more smaller, and very fine particles will become coming from the last sieve. The efficiency of the sifters basically depends upon the uniform size of the produce, and due to the uniform size, sifter efficiency improves. So if the size is uniform for the product, the sifting is more efficient and it will be more better. So the sifting operation may not be 100% efficient if the product are not uniformly spherical or round. So if the product is spherical or round uniformly, the sifting process will be better, faster, and more efficient and appropriate. But if the size of the product or the shape of the product is not spherical or round, or it like it's not uniform, so the sift, it will affect the efficiency of the sifting process. In such situations where there are irregular shapes, so the sifting operation becomes very difficult and does not clean the product efficiently. So the product cleaning will not take place efficiently. Like here it is saying that the sifter removes particles of the wrong size using a set of vibrating screens, so which is correct, we just now saw. Then the efficiency of the sifters depend on the uniformity of the product shape and size. So which is also correct, as we discussed just now, that the uniformity of the product or the product shape and the size must be uniform for good efficiency of the sifting process. And then third is saying that the sifting is always 100% efficient regardless of the product shape, which is wrong, because if the product shape is irregular, obviously the efficiency of the sifting process will going to be affected. So the fourth statement is saying that non-uniformly shaped products, it will going to reduce the efficiency of the sifting process. So which is correct, that the irregularly shaped products will definitely going to affect the efficiency of the sieving process or the sifting process. So this sifting process, so statement 1, 2, and 4 are correct. Option B is correct here. And this sifting process is basically used also like for the classification of the particles or the powders. Like there will be different, as we discussed here, that there will be different set of or the series of the sieves can be there one above another, and the different particle size will be separated. The larger one will come first, and the smaller one will come last. So like this, different particles in between also can be separated using this sifting process. So one uh, application is that we can classify the different size or shape of the product using this. And then second is the filtration or impurity removal. So the foreign materials or the particles can be removed from this. Basically, the impurities can be removed. So the foreign particles or the agglomerates can be removed from this. So how? Because suppose this is a foreign particle. So the foreign particle will have suppose a larger diameter, and the desired particle or the product particle will have the smaller particle size. So the foreign materials can be uh, left during the sieving process. It will be left at the top of the sieve, and the particles which is the desired one will come as from the pass from the sieve and can be collected at the bottom of the sifter. Then filtration process can be done. Suppose we have, so it is basically used for the removal of particles or the foreign materials from the liquid as well. So liquid particles are having very low particle size. So those can pass through the sieve easily, whereas uh, the foreign particles, they will have the more particle size, so they will come above the top of the screen. So these two fractions can be separated, like the liquid and the foreign particle, and can be uh, used. These sifting process can be used for filtration process as well. Okay, I hope so far is clear to everyone. So now we are moving to the next concept, which is sorting and grading. So what is the difference between sorting and grading? The sorting basically refers to the separation of the foods into categories based on a measurable physical property, such as weight, size, shape, density, and color. The sorting we are doing based on some physical property. There is a difference between the physical property, like there can be difference in the different weights, or maybe size or shape or color, or or density. Maybe some particles are lighter and some are heavier. So sorting is basically done on these basis on of these measurable physical properties, whereas the grading process is done, and it is basically the classification on the basis of the quality of the product, whether the quality of the product is good or bad. Or so we grade food products, and the different grades of the food product can be sold at different prices. So the good uh, good grade of the product, so it can be sold at very higher prices, whereas the grade C product can be sell at lower prices. So the produce is classified into two or more grades on the basis of their surface color, then shape, size, weight, soundness, firmness, cleanliness, and maturity to obtain the maximum worth in the market. So if the product, like suppose if some product is having the very high maturity, or it is like about to spoil, so it will be of low grade and it will be sold at low cost. And if some product is of high grade and its shelf life is higher, so it can be sold at higher prices in the market. So this is the basically grading can be done based on the, like this is the smaller, like when the pineapple is in the initial stage, its weight is also less and its dimensions is also less, and it is more of the green color. But when it will be ripened, so its weight will be more, and its size will be more bigger, and it will be more towards yellow color. And then so we can grade different products based on these properties, like the color, size, shape, weight. So we can grade these pineapples in different grades. Then this is the orange. So this is the orange, which is basically having the lesser diameter and lesser weight, and this is of the more diameter and more weight. So this can be put into another grade, and this orange can be put in another grade. Then this is the mango. Here in this table is a mango of different varieties. So this mango, if we see, this is having some black spots like these. So they can be of lower grade and they can be sold at very low price because it's about to spoil. Whereas this mangoes are the average grade, and this is the good grade of mangoes. So these good grades of mangoes can be sold at higher prices. Okay, so let's discuss one question regarding this, like how we are separating and grading. So this question basically it is about the like cleaning. It is regarding like cleaning, not specifically for the sorting and grading, but this question is basically regarding how we are cleaning, like the previous set of the questions, which is about how when we are cleaning the fruits, vegetables, spices, and the condiments. So which of the following best describes the operating principles of a destoner used for separating the stones and other heavy impurities from the grains? So first option is saying that separation based primarily on differences in size using a series of perforated screens. Then B is saying that separation based on differences in densities and aerodynamic behavior using an inclined vibrating deck and controlled air flow. C is separation based on differences in magnetic susceptibility between grains and stones. Option D is separation based primarily on the differences in color using the optical sensor. So this is the question regarding removing of the impurities from any grains. So it is saying that we use basically destoner for removing the stones from the grain. So what is its main principle on which this destoner works on? Okay, let's see the answer. So basically, destoner works on the principle that its separation will be there based on the density differences and the aerodynamic behavior using an inclined vibrating deck and controlled air flow. So these destoners basically, it works on the principle of separation based on the density, size, and shape of the product. So the destoner basically works with the same principle as the air tables and are generally smaller than the air tables, and they are used to remove basically the heavy stones and the pieces of the rocks, whereas these air tables they basically separate based the products into many different groups as we require. So this destoner is usually separating the heavy impurities like the stones, glasses, and the metal pieces from the grains, because these impurities are of the higher density. So suppose inlet is here, these grains with the impurities will come, then it will go here. From here, in this destoner, air will come from the bottom to this platform or to this sea, to this, like it will be like inclined sieves will be there. One like long sieve will be there, which is having some mesh size like this, and over this the product is there with the stones, and from the bottom air will come, and because of the density, the heavier products, which are the like the rocks and the metals, heavy metals, they will be at, they'll not float, whereas the grains, because of their low density, will float in the air. So, and this sieve is vibrating. So when it will vibrate to and in the to and fro motion, the stones, it will, when it will go here, this sieve, the stones will come and fall at the bottom, right? This from here, the stones will come. And since the grains, they are floating, and when the sieves will go in the forward motion, in the when during the vibration, the cleaned products will be separated and come out at the another end. So these stones and the heavy particles, based on their size, shape, and the density, they will be separated from the clean products in destoner. Then they'll be separated because of the high density. So the vibration and an upward air stream will going to cause the lighter particle to move differently from the heavier particle. So that will help for the separation. So the airflow and the inclination and the vibration of the screen and the type of screen we are using are adjusted based on which kind of the material we want to separate out. So this is the destoner, industrial destoner. And this is the air table. Air table is also similar as the destoner basically, but it is it only works based on the density. So what will going to happen? It is in air table. It is an inclined sieve kind of uh, inclined sieve. Inclined sieves will be there. So based on the, like here, feed is there. Suppose so here feeding zone is there. So based on the slope and based on the vibrations and the particle size, different particle size will be collected at different locations like this. Okay, I hope this question is clear that in the stoner, based on the density and the aerodynamic behavior of the particles, and also the inclined vibrating deck and controlled airflow, the heavier stones will be separated from the lighter grains. Okay, so this is the question regarding the regarding the cleaning of the grains. So we already discussed. Now we will be going to discuss about sorting and grading of the products. So the sorting, basically, as we already discussed, that in the sorting, what is the difference between sorting and grading? That sorting is basically we are uh, classifying based on the physical property, whereas in grading we are classifying based on the different properties. We are basically here, the main purpose is to classify the product based on its quality or different, like A grade, B grade, C grade. So the different qualities can be marked of it in a food product because of its commercial or, and we can decide its market worth or market value. So there are different like there are different graders we use for grading purpose. So there are different graders such as the screen graders, diverging belt grader, barrel screen graders, roller graders, link graders, Aries graders, and mass graders. So these are the different graders we use for grading of different food products or the fruits and vegetables. So, and the new innovations which are there in the grading system of fruits and vegetables and the spices are like computer weight grader. So it is basically classifying based on the weight, but the computer systems are or the softwares are basically included. And then video image capture and analysis system, then NIR spectrometers, then X-ray imaging and computer-aided tomography. Next is magnetic resonance imaging, MRI, and then spectroscopy, acoustic methods, and last is the volatile emission analysis. So these are the different new methods which can be also used for grading the fruits, vegetables, and the spices. So now let's discuss the question regarding the grading. So for which of the following products an electronic color grading machine is preferred? Perishable, semi-perishable, highly perishable fruits, or can be used for any of the above? Okay, let's see the answer. So these electronic color grading machines, they are basically used for highly perishable fruits. So this thing in the color, basically the maturity is basically measured, and also the presence of any defects like the browning or any defects is there, or the degree of processing can also be checked using the color graders. So the colors, there are color graders and the color sorters are also there, and they can be both manual and automated. In the manual, conveyor belts will be there, or the sorting tables will be there. And in automated, highly accurate photo cells which compare reflectance of the product. So the product color can be checked based on the transmission, absorption, and reflectance in the product. In a, like the we can compare from the fresh produce what is the reflectance, and in the spoiled one what is the reflectance. So there can be some difference in the reflectance of both of the products. It can eject defective or wrongly colored product like the blackened small fruits, usually by a blast of compressed air. So one compressed air, like so the whichever uh, food product which is of low grade can be separated using the pressurized air. Then number of photo cells positioned at different angles can detect the blemishes on a large unit such as a potato, red and green tomatoes. So in the big industries, there can be number of photo cells placed at different angles, which can detect which one is the fresh one and which one is of the low grade product, and it can separate those low grade products from the higher grade products using the compressed air. Or we so some grade so the gradings basically can be done using like electronic color grading, which we are talking about, and it is usually used for the highly perishable food products. And when we are doing the grading based on size, it can be like for onion, potato, apple, tomato, and screen graders can be used for pear, lemon, and anola. Size and color graders can be used for the citrus fruits like lemon, tangerines, oranges, like those products. So these color sorters or the color graders, they basically how they work. So the fruits and vegetables like the tomatoes, apples, and the oranges, they can be quickly sorted automatically using the microprocessors, controlled color sorting equipment. So here from the feed hopper, this different food products can come, and then it will come in the region where different photo cells are placed at different angles here. So suppose these are the good one and it is a spoiled. So this is the spoiled one. So it is sensing that this is here, the sensors are sensing that this is the spoiled one and sending the signal. And here, based on the signal is processed, the ejector is ejecting all the rejected material and it is separating the accepted and the rejected materials. So this photo detectors measures the reflected color of the produce and compare with the standards, and the reflected light is basically processed by a microprocessor which operates rejection system automatically. So this electronic color grading is preferred for highly perishable products, because also like based on this color grading in industry, like we can automatically separate materials in the very bulk amount also. And if the material is very highly perishable, the colors can be very quickly changing in any fruits and vegetables. So they can be used. And also in color sorters, what happens basically, image is basically processed and the segmentation is done, and the defective product can be separated from the non-defective product, and ripe product can be separated from unripe products based on the color. So here highly perishable fruits basically can be sorted using color grading system, electronic color grading machine. Okay, let's discuss this next question about which of the following statements are correct regarding roller graders. So four statements are there that roller graders work on the principle of diverging elements that increases in width. Then they are suitable for spherical fruits like oranges and tomatoes. Third is they can effectively sort produce by both the shape and the size. And one limitation is their inability to differentiate between longer and the shorter items. So we need to answer which one is the correct here. So answer D is correct. If 1, 2, and 4 statements are correct. So these ruler graders basically, they work on the principle of diverging elements where the produce is conveyed by a series of rollers which get wider and wider as it moves along. So the smaller fruits or the vegetables, they will drop first, and the larger one, it will carry forward and it will drop at the end. It uses rollers that basically diverges to sort by size. It cannot differentiate shape. Specifically, it struggles with longer and the shorter produce. So this roller grader basically works on the principle of diverging element that increases in width, which is correct. And they are suitable for the spherical fruits like the oranges and the tomatoes, which is also correct. And they can effectively sort produce by both size and shape, which is wrong because it can only separate based on the different, sorry. Yeah, so it can only separate the smaller fruits from the larger fruits, and its limitation, which is correct, that it is having this drawback that it can not differentiate the smaller and the longer items. It is true that it cannot separate effectively. So this roller graders, they are basically suitable for spherical fruits like tomatoes, oranges, and the apples. So here, suppose we are putting apples here, and then this is the roller grader. So here, sorting is done basically based on the size. So there are like different, like this, there are different shape uh, of the apple will come on these different roller graders. So based on the smaller fruit, so here the gap is small. So the smaller fruits can pass then. So the smaller fruits can come first and the larger fruit can come last at the last. So suppose here we have the different fruits and here different diameter circles are there in the roller grader. So which the smaller one will come first from here and the larger one will come at the end from here. Okay, let's solve this numerical question. So here Basically, we already discussed that D option, which is 1, 2, and 4 is correct here. Let's solve this numerical question, which is on the basis on the size reduction and also on the Rittinger's law. So a food material is to be ground from an initial average particle size of 1.5 mm to the final particle size of 0.75 mm. The energy required to achieve this size reduction is 25 kilojoule per kg. We need to calculate the energy constant kilojoule mm per kg for this process using the Rittinger's law. Okay, let's solve this question. So we already know that in the size reduction laws, there are the three laws: Hicks law, Rittinger's law, and the Bond's law. So when we are reducing the particle size from larger to smaller of any particle, any food particle, so there are these three laws take into they will play their role. So the Rittinger law, it will work like it is. It says that the work used for a particulate size reduction is directly proportional to the new surface reduced. So this law is basically useful in fine grinding where a large increase in surface is resulted. So the formula is E equals to K R bracket 1 upon XP minus 1 upon XF. So E is basically here telling that the energy used or the work done for the size reduction, and Kr is the Rittinger's constant 1 upon Xp minus 1 upon Xf. So this is the basically the dimension of the P means product. So 1 upon the dimension of the product minus 1 upon Xf, which is the for the feed. Okay, so let's come to the solving the question. So in the question, it is said that a food material is to be grounded from an initial particle size of 1.5 mm to the particle size of 0.75 mm. It is the particle size is reduced, and for this, around 25 kilojoule per kg of the energy is consumed. So we need to here calculate the Rittinger's constant in this question. So as we already discussed that this is the Rittinger's law. E equals to Kr 1 upon Xp minus 1 upon Xf. So from Rittinger's law, we can, from here, we can get that this Kr, what is its value? So this Kr would be equals to E upon this value, right? 1 upon Xp minus 1 upon Xf. So Kr is equals to basically E upon 1 upon Xp minus 1 upon Xf. So Kr, which is the energy constant we need to calculate, is equals to what is the energy E is given. E is required to reduce the particle size, which is 25 divided by 1 upon Xp. Xp means final particle size, which is reduced in the product. So the final is 0.75 mm. So 1 upon 0.75 minus 1 upon Xf. So Xf is the initial size of the particle, which is 1.5 mm. So 1 upon 1.5 here. So which is equal to 25 divided by 1 upon 0.75, which is 1.33 minus 1 upon 1.5, which is 0.667. So 1.33 minus 0.667 would be 0.663. So 25 divided by 0.663 would be 37.71 kilojoule mm per kg. So answer is B here. I hope this question is clear to everyone. Now this question is regarding Bond's law. So corn variety V1 basically with an average particle size of 20 mm needs to be crushed to a particle size of 5 mm. So here energy is required in this process is 18 kilojoule per kg energy. And if other conditions are keeping similar, so what will be the energy requirement kilojoule per kg to crush the other corn variety V2 from 25 mm. So this V2 from 25 mm to 3 mm. So how much as the energy will be required if we are keeping the other conditions similar? Okay, let's solve this question. Let's talk about the Bond's law. So the Bond's law basically states that the work used to reduce particle size is proportional to the square root of the diameter of the particles produced. So it is used for the intermediate grinding of the product. So it is basically P by F, which is power divided by feed rate, is equals to this 0.3162 Wi. Wi is basically work index multiplied by 1 upon x under root xp. Xp is basically the product diameter minus 1 upon x under root xf, which is the feed diameter. So the requirement in kilowatt hour per ton of the feed need to reduce a very large feed to a so this law is basically using for the intermediate grinding. And here we say that uh, we are saying that the product diameter. So product diameter is basically, if we are saying that the product diameter is uh, suppose 75 mm or something, so that means that 80% of the particles are of this dimension. So the requirement in kilowatt hour per ton of the feed needed to reduce a very large feed, suppose such as an 80% of the product pass through a 100 micrometer of the screen. So 80% of the particle must pass through this particular dimension of the screen. So let's come to the question. So variety V1, which is having 25 mm kernels, it is being the particle size is reduced to 5 mm particle size, and the energy required is 18 kilojoule per kg. And in variety 2, the size reduction is from 25 to 3 mm, and we need to calculate E2 using the Bond's law. So we have the initial particle size of V1 20 mm, final particle size of the corn variety V1, which is 5 mm. Initial particle size of the variety V2 is 25, and the final size of the corn V2 is 3 mm. So we can apply this equation. So the energy required for grinding of the variety V1 is 18 basically, and for V2 variety we need to calculate. So as per the Bond's law, E is equals to Kb. So here this is E basically. So this is P by F is E. So E equals to, this is this work index, and 0.3162 is we are putting as Kb. So Kb equals to Kb multiplied by this factor 1 upon under root xp minus 1 upon under root xf. So this is equals to Kb 1 upon under root xp minus 1 upon under root xf. So E1 divided by E2 will be, this Kb will be removed, and it will be 1 upon xp of variety 1 minus 1 upon under root xf1 divide by 1 upon under root xp2 minus 1 upon under root xf2. And these values are given already, that xp1, which is the product dimension for variety 1, is 5, and for feed it's 20. So 1 upon under root 5 minus 1 upon under root 20 divide by xp2, which is 3 to 3, and xf2 is 25. So xp2 is 1 upon under root 3 and 1 upon minus 1 upon under root xf2, which is 25. So when we solve this, 1 upon under root 5, so under root 5 is 2.24 minus 1 upon under root 20, so under root 20 is 4.47, divide by 1 upon under root 3, which is under root 3 is 1.73, and under minus 1 upon under root 25, so under root 25 is 5. So further solving, 1 upon 1.24 would be 0.446 minus 1 upon 4.47. So 1 upon 4.47 would be 0.224. Divide by 1 upon 1.73. So 1 upon 1.73 would be 0.578 minus 1 upon 5. So 1 upon 5 would be 0.2. So we can get this. And even we know already from the question, it is 18. So this equation will be like this now. So 18 divided by E2 equals to 0.446 minus 0.224, which is 0.222, divided by 0.578 minus 0.2, which is 0.378. So 0.222 divided by 0.378 would be 0.587. So this equation is now 18 divided by E2 equals to 0.587. So E2 will be, this will come here, and this will be here. So 18 divided by 0.587. So 18 divided by 0.587 is 30.664 kilojoule per kg is the E2, which is B. Okay, let's discuss now Kick's law. So rice is milled from 7 mm to 400 microns using a 10 HP motor. Using Kick's law, calculate the HP horsepower requirement of the motor to reduce a particle from 7 mm to 150 microns. So rice is milled from 7 to 400, 7 mm to 400 microns using 10 HP motor power, and then from the Kick's law we need to find how much is the power required when we are reducing from 7 mm, this 7 mm to 150 microns. Okay, let's see the Kick's law. So Kick's law basically states that the energy required for size reduction is basically proportional to the particle's initial size. So this law is particularly useful in coarse grinding or coarse crushing of the particles, where size ratios are more significant than the surface area changes. So E equals to Kk. So this E is energy required per mass of the field equals to Kick's constant multiplied by ln xp by xf. So xp is average particle size of the feed in diameter divided by average particle size of the product in the diameter. Product diameter. So the product divided by the feed particle size. Okay, so let's solve this question. So according to Kick's law, E equals to Kk ln xf by xp, or xp by xf, sorry, product divided by the feed, right? Okay, so E is given as E is given as 10 horsepower motor. So E energy is 10 equals to Kk ln So the particle size is reduced from 7 mm to 400 microns. So here it would be 7 mm divided by 400 microns. Means if we convert into microns to mm, it would be 400 divided by 1000, right? It would be 0.4. So divide by 0.4 equals to kk ln 7 divided by 0.4 would be 17.5. So ln 17.5 is basically 2.86. So here it would be 10 equals to k into 2.86, right? So k would be 10 divided by 2.86. So that would be 10 divided by 2.86 would be 3.494, right? Now for this is the constant we got already. Now we can again use the same equation for second reduction, which is 150 microns of the particle size reduction. So E would be kk, which is 3.494 ln. So here we are using this, right? So for both of this, we are using this, that xf divided by xp, right? So xf, which is ln, xf is, which is a initial particle size 7 mm, and it is reduced to divide by 150 microns, which is 150 microns divided by 1000 would be 0.0.15 mm. So 7 divided by 0.15. So it would be 46.67. So ln 46.67 would be 3.843, and it will multiply by 3.494. So that would be 13.43 horsepower. So it is around 13 to 4, like around 13 to 14 horsepower is required when we are grinding from the particle size from 7 to 150 microns. Okay, so basically these are the three different laws: Rittinger's law, Bond's law, and the Higgs law. When we are doing the particle, when we are discussing about the reduction of the particle size and how much is the energy required to do so. And this so the Walker and the Shaw basically gathered this Bond law, Higgs law, and Rittinger's law in one, based on the fact that these laws come from one differential equation. So this is the common equation for these law. And here, if n equals to 1, if this n is equals to 1, basically this is dE, which is for energy, equals to minus k, which is for constant, and d by d to the power n, which is for the product dimensions. So if n is equals to 1, it is for the Higgs law, and n is 1.5. This is 1.5 basically. That is for Bond's law, and n is 2 for Rittinger's law. And n is not constant, and it basically depends on the particle size. So this is a plot. In y-axis energy, and on d-axis the diameter. So this diameter is basically, if we are grinding any food particle, so the 80% of the particles will have that particular diameter. So that diameter is taken as d. So the so when we are this Walker and Shaw, they basically what they did is so they gathered this Bond's law, Higgs law, and Rittinger's law together, and they make one equation. And when we are plotting this equation, when we are plotting this equation, so basically this y-axis is basically the energy, and on the x-axis, this is DAT. So DAT is basically when we are grinding one particle or when we are reducing some particle size from one dimension to another. So what will happen is basically the 80% of the particles, if they have the same amount of diameter, so that DAT will be using in this x-axis. So the energy consumption for basically the intermediate and the fine grinding and the ultra fine grinding of this lignocellulosic biomass, they are basically put in the different this Rittinger's bond and Kick's law in this graph. So basically what is happening, if the Kick's law, basically we said that n is equals to basically 1. So this is following this line. And when n equals to 1.5, it is Bond's law, and n equals to 2, which is the Rittinger's law. So the Rittinger's law is basically used for the ultra fine grinding, and Bond's law is basically used for the fine grinding, and Fick's law is basically for the intermediate milling, right? So the slope is basically very high, which is n equals to 2, is very high for this Rittinger's law. That means when we are reducing the particle size to a very fine particle, as the diameter will come very low diameter, so the energy required will be very, very high for ultra fine grinding. Whereas when we're grinding the particle size to an intermediate level, so what will going to happen? The energy required will be little lesser as compared to the ultra fine grinding. So I hope this so far is clear to everyone. All the numericals we discussed about the different size reduction processes. So I hope all these are clear to everyone. Okay, so now let's discuss about the numericals which are regarding the separation or the cleaning process, how efficient the cleaning process is and the separating process is. So first question is regarding an air screen grain cleaner unit of capacity 1 ton per hour with 2 screens was evaluated with a feed containing 8.5% impurities. During the operation, the clean grain at blower outlet, overflow of first screen and underflow of the second screen basically were found as 0.3%, 1.2% and 0.8% respectively. If the clean grain contains 0.6% of the impurities, the cleaning efficiency of the cleaner unit in percentage would be. Okay, let's solve this question. So it is given that the capacity is 1 ton per hour and the feed containing is about 8.5% impurities. Clean grain at the blower outlet is 0.3%, and like the impurities present in the clean grain would be at 0.3%, and the overflow it's 1.2, and for underflow it's 0.8. So the clean grain contains basically 0.6% of the impurities. So we need to find the cleaning efficiency. So feed in the image from the in the picture we can see that the feed is going 1 ton per hour and it is having 8.5% of the impurities. So it is going in two screens, first and the second. So in the first screen, 1.2% impurities is coming, and in the second screen, 0.8, and in the clean grain blowers, it is 0.3%, and in the total final grain, it is around 0.6% of the impurities are there. So we need to calculate the cleaning efficiency in this process. So we can have the two approaches to do so. Yeah. So the cleaning efficiency basically is impurities which are removed divided by the total impurities into 100. So the impurities which are removed is basically the total impurities in the feed is 8.5%, and in the final uh, product the impurity is this 0.6% in the final feed cleaned grains, right? So when we subtract it like that, in the initial, how much is the impurity in the feed, which is 8.5, minus the in the clean grain, what is the impurity? 0.6. So we can get the how much is the impurity removed, divide by the total impurity, which is in the feed, which is 8.5 into 100 is the cleaning efficiency. So 8.5 minus 0.6 will be 7.9 divided by total, which is 8.5% impurity into 100. So 7.9 divided by 8.5 into 100 would be 92.94% of the impurities. Uh, so, sorry, 92.94% of the cleaning efficiency. One way of doing this is 90 this way, and the another is which is a proper calculation. If we are doing like the 100, this is a approximately it is telling. Okay, 92.94% can be the uh, cleaning efficiency, but when we are doing basically when we are doing the proper calculation or taking all thing into account, so how we can solve this question? It is, so this is approximate answer here. So feed is basically 1 ton per hour. So it is basically 1000 kg per hour. And the impurity in the feed is basically equals to 8.5%, right? Here it is saying that impurity in the feed is 8.5%. So 8.5 divided by 100 into, so 8.5% of the feed, right? So 8.5 divided by 100 into 1000 kg per hour of the feed. So what is the impurity? 85 kg per hour is the impurity. Now, clean grain at the blower output is having 0.3% of the impurity, right? Which is equals to 0.3 divided by 100 into 1000. So it is 3 kg per hour. And in the overflow of the first screen, it is 1.2%. So 1.2 divided by 100 into 1000, which is 12 kg per hour. In the underflow of the second screen, it is 0.8%. So it equals to 0.8 divided by 100 into 1000. So that is 8 kg per hour. So the total material which is removed is this sum 3, 12 and 8, which is 23 kg per hour. So the clean grains which is coming out of the cleaner is basically, this is basically removed materials, and total material is this 1000. So 1000 minus 23, which is 977 kg per hour, will be the total grain coming out of the cleaner. And in this total grain, 0.6% is impurity. So 0.6 divided by 100 into this 977. So that is 5.862 kg per hour is the impurity containing. Although the cleaners remove a total of 23 kg per hour of the material, but not all that material is the impurity. Some good grains is also lost with the separated material. So the impurity removed is basically, as we already discussed, impurity in the feed minus impurity in the final clean grain, which is in the feed, it is here we calculated 85 minus the total in the basically cleaned grain, which is 5.862, which is equals to 79.138 kg per hour is the impurity removed. And when we divide this by the total impurity in the feed, which is 79.138 divided by total, which is 85, the total impurity 85 into 100, that would be cleaning efficiency. And it is basically 93.1%. This is the exact answer basically. I hope this question is clear to everyone. Now let's move to this question. A tray type paddy separator basically used to separate paddy from a binary mixture of the paddy and the brown rice feed at the brown rice. So basically there is a paddy separator, tray type paddy separator is there, in which paddy is basically separated from the brown rice. So this mixture of paddy plus rice is basically fed at the rate of 600 kg per hour. So the mass fraction of the paddy in the feed, basically in this feed, mass fraction of the paddy is 0.2. When the paddy and the rice is separated, the separated paddy and the separated rice, they are having this fraction 0.7 and 0.02 respectively. So the mass of the 1000 paddy grain is basically given as 24.5 gram. So we need to calculate here in this question the separation efficiency and the number of the paddy grains recycled per second respectively are. Okay, let's solve this question. So basically feed is having the basically this paddy and brown rice, and it is 1600 kg per hour, and the mass fraction of the paddy in this is 0.2. So the paddy in the feed is basically 1600 into 0.2, which is 320 kg per hour is the paddy in the feed. And then what 1 minus 0.2, which is 0.8, is the brown rice fraction in the feed. So brown rice in the feed would be 1600 into 0.8, which is 1280 kg per hour. Now in the tray type paddy separator, this is separated paddy we get and the separated rice we get for this mass fraction. So mass of the paddy in the separated paddy is 0.7 and separated rice mass fraction of paddy, so mass fraction of, sorry, okay, yeah, we were discussing this question. Yeah, so in the separated rice, yeah, so in the uh separated rice, the paddy fraction is 0.02, and in the separated paddy, uh, the mass fraction of paddy is 0.7, which is 0.7, right? So in the separated paddy, basically, the mass fraction of the paddy is 0.7, right? So how much is the fraction of the brown rice in the separated paddy? It would be 1 minus 0.7, which is 0.3, right? 0.3 is the mass fraction of the brown rice in the separated paddy. And in the separated rice, mass fraction of the paddy is 0.02. So the fraction of the brown rice would be 1 minus 0.02, which is 0.98. So basically, as we discussed, that's in the separated paddy, the paddy fraction is 0.7, right? So 1 minus 0, so that is 0.7 P. So we are multiplying by P. So how much is the amount? Because we don't know what is the amount we get in the separated paddy. So we are considering assuming it as P, and the rice we get from here is R. So P kg per hour and R kg per hour. So in separated paddy, 0.7 into P kg per hour is the paddy, and 1 minus 0.7, which is 0.3 P kg per hour is the brown rice. And in the separated rice, 0.02 R kg per hour is the paddy, and 1 minus 0.02, which is 0.98 R kg per hour is a brown rice. So basically in the feed, which is this feed, this P and R is equal to basically this P paddy and R brown rice. Their summation is basically 1600 kg per hour, which is on like it is their mix, this mixed paddy and brown rice. It is given in the question that it is the feed is total 600 kg per hour. That is equation 1. And in separated one, if we see this one, separated rice, so 0.98 R is the rice, brown rice, plus 0.3 is the, I'm so sorry. Yeah. So in the separated one, in like here, in this, so in the separated one, if we see the brown rice only, so brown rice is 0.98 R is the brown rice, plus this in the separated this paddy, this is also brown rice, right? So 0.3 P equals to total of the brown rice, which is here we calculated that the brown rice in the feed is 1280 kg per hour, which is equals to 1280 kg per hour. So when we divide equation 2, this equation, this one by 0.3, so it would be 0.98 divided by 0.3 R plus 0.3 divided by 0.3 P, and equals to 1280 divided by 0.3 kg per hour. So 0.98 divided by 0.3 would be 3.267 R plus 0.3 divided by 0.3 P is 1 P, which then equals to 1.1280 divided by 0.3 is 4266.67 kg per hour. Then we are subtracting this equation 1 from this 3. So we can see here one equation is P plus R P plus R is equals to 1600 is equation 1, and we are subtracting it with equation 3, which is 3.267 R plus P equals to 4266.67. So it would be this P would be cancelled with this P, and it would be R, this R minus 3.267 3.267 R. So this P would be cancelled, and R minus this 3.267 R equals to this 1600 minus this 4266.67. So R minus 3.267 R would be minus 2.267 R equals to this 1600 minus 4266.67, which would be minus 2666.67. So minus would be cancelled both sides. Then R equals to basically 2666.67 divided by this 2.267 which would be 1176.3 kg per hour is the R. Now we can put the value of R in the equation, this third equation. So P would be 4266.67 minus 3.267 into R. R would be, R is already calculated as 1176.3. So this 3.267 multiplied by 1176.3 would be 3842.97, and that would be subtracted from 4266.67. So we'll get P as 423.7 kg per hour. So this we calculated that how much is the P value, which is the paddy which is coming out. So in the now we can calculate in the paddy separator this one efficiency. Then we can calculate this one efficiency separately. Then we can calculate the overall separation efficiency, which we need to calculate in this question. So the the paddy separator efficiency is equals to amount of the paddy collected per hour in paddy separator divided by the total paddy supplied in the field. Right? So it is equals to the amount of the paddy collected per hour in the paddy separator would be this fraction into P, right? So 0.7 into the P value, which is 423.7 divided by the total paddy in the feed, which is we calculated here. The paddy feed is 320 kg per hour. So it would be 0.7 multiplied by 423.7 is 296.59 divided by 320, which is equals to 0.927. Now, similarly, we can calculate brown rice separator efficiency. This one. So, which would be amount of the brown rice collected per hour in the separator divided by the total rice supplied in the field. So that would be, so the brown rice fraction is 0.98, which here we can see, multiplied by the brown rice, which we calculated, 1176.3. So it would be divided by the total rice supplied in the field, which is here 1280. So divide by 1280 here. So everything is fine, right? Yeah. So 0.98 multiplying 1176.3 is 1152.774 divided by 1280, which is 0.9. So now the separator efficiency is paddy separator efficiency multiplied by brown rice separation efficiency, which is 0.927 multiplied 0.9. It will be 0.8343, which is this D option. Now we need to calculate the number of the paddy grains recycled per second. So we know already mass of 1000 paddy grains is 2.5 grams, right? So the number of paddy grains recycled per hours will be equals to the fraction of the paddy, which is this 0.7 multiplied by how much is the paddy we are getting, 423.7 from here, multiply by, now this is 423.7 is in kg per hour, right? 0.7. This is the fraction of the paddy. So 0.7 into 423.7. This is kg per hour. So we can convert it into gram per second. This so what we can do, we can multiply by 1000 to convert into gram, and for second multiply by 60 into 60, which is 3600. So 0.7 multiply to so multiply 423.7 into 1000 divided by 3600 would be 82.386 gram per second, right? Now we need to calculate that the number of the paddy. This is a now we can calculate number of the paddy recycled per second. How much is the paddy? This is the paddy recycled per second. Now we are calculating about the grains. How much is the grains is recycling, right? So grains is this. This is the total. We are calculating how much is the paddy, like amount of the paddy. I'm so sorry. This is the amount of the paddy which is recycling per hour, right? Now we need to convert it into the number of the grains which is recycling per second, right? So this is the this much of the this is the paddy rate which is we getting. So 82.386 gram per second is the paddy which we are getting, right? Is the rate of the paddy. Now we can multiply. Now we can divide this by the grains, like the we can divide it by this mass which is 24.5, and we can multiply by this 1000. So basically this is for one paddy grain, the mass is this. For 1000 paddy grain, mass is 24.5 grams, and for 1 grain of this paddy, the mass is 24.5 divided by 1000. So we can this rate 82.386, when we divide by for the mass of the 1 grain, it will be 24.5 divided by 1000. So 1000 it will come up. So 82.386 into 1000 divided by 24.5 is 3362.7. So this is the number of the basically paddy grains recycled per second. So option D is correct here. I hope this question is clear to everyone. Okay, now let's discuss about the peeling. So which of the following statement is correct regarding the benefits of peeling? So four statements we have: that peeling improves the palatability of the fruits and vegetables. Second is peeling can reduce pesticide residues. Third is that peeling increases the drying rate or osmotic dehydration rate. And fourth is peeling increases the activation energy required for drying. Okay, let's see answer that basically 1, 2, and 3 options are correct here. So basically peeling is basically a process of removing the unwanted or inedible material and to improve the appearance of the final product. So it is primarily unit operation for preparing the fruits and vegetables for the processing. So this peeling basically is done for the purpose to minimize the cost by removing as little of the underlying food as possible. And it is done to leave the peeled surface cleaned and undamaged, and to reduce the energy, labor, and effluent treatment cost to a minimum. The benefits of peeling is that it helps improve the texture and the flavor, thus it improves the and overall palatability. Then it removes outer layer where the pesticide residues are often present, and when the peel is removed, so the faster moisture removal can be there, so it enhances the drying or osmotic dehydration rate. Also, it decreases the activation energy for the drying and making the process more efficient, and it enhances water diffusion coefficient also. But when there is an inappropriate peeling, so it may lead to high peeling losses, low process efficiency, high water and energy consumption, and increase in the economic losses as well. So we know already that there are different methods of peeling, like manual peeling, mechanical, which is abrasive and non-abrasive, and chemical peeling, which is having this live peeling, and then chemical thermal methods like the hot water, using hot water, steam, and the infrared or the flame and the ultrasound, and enzymatic peeling. And these peeling, basically this peeling of fruits and vegetables, they can be done using this conventional method like the using hot water, steam, and the lye. So uh, also it can be used using the different novel methods like enzymes, infrared radiation, ohmic heating, and the ultrasound methods. So we can have the peeling using these different methods. So here in this question, that the peeling improves basically the palatability of fruits and vegetables, which is correct. And the peeling reduces basically the pesticides residues, which is correct. And the peeling increases the rate of the drying or the osmotic dehydration process, which is also correct. And the peeling basically it decreases the activation energy required for drying. It doesn't increase, so that is wrong. So option A is correct in this case. Okay, now this question is about dicing. So small dicing of the fruits and vegetables of around 6 mm dice are known as. So which by which name we say that it is a small dicing, or of the 6 mm cubes we get when, so which type of dicing it is. So it is basically mesh doing. So basically dicing is done by cutting the produce into three mutually perpendicular planes. So the material is cut into the slices, and the technique starts with the produce getting sliced and then cut into strips by the rotating blade. So this is the rotating blade, circular blades are there. So this this is a slicing knife, and it is cutting the product into the slices, and the strips are then fed into the second set of the rotating knives that operates at the right angle to the first set and cuts them into the cubes. So it is now second knife is cutting into these slices into the cubes. Based on the how much particle size, how much is the cube size we get, that is known, these dicings are termed as different names. So if the fine dicing is there, that means the cutting of the vegetables into the small cubes of precise and uniform measurement, and it is like around 1.5 mm or 1/6 of the inch. So that means it is the fine dicing or the brunoise. And if the dicing is done and we get around 6 mm dice or 1/4 of the inch, and it is used for the soup, salads, and the larger fruits. So it is known as the mesh doing or the small dicing. If the particle size is little more bigger, so like around 1.5 centimeter, so it is the medium dicing or the parmentier. And if the dicing is, the cut pieces are cubes are the very large size, around 2 centimeter or 3/4 of the inch, that is known as large dice or carrer. So in this question, around 6 mm dice is mesh doing, small dicing. Okay, so let's discuss about the packaging now. So in assertion, it is saying that the packaging material should be non-toxic and compatible with the specific product. or the produce, and the reason is that the packaging is expected to resist tampering, be low cost and easy to open and dispose of. So we need to tell if the assertion is true and the reason is true, and if the reason is correctly explaining the assertion or not. Okay, so here that the assertion and the reason are true, and reason is basically not correctly explaining the assertion. So the basically packaging of any food product, it means or it is the means or the system in which the fresh fruits and the vegetables or the processed products, it reaches from the farm or the production unit to the final destination in the safe, sound condition and at affordable price. So there are different packaging can be used like bags, carrots, hamper, baskets, cartons, bulk bins, pallets, containers different and are so that the handling, transportation and the marketing is easy, convenient and can be done properly. So the packaging function is basically to contain the product. So it basically contain the product. So it basically prevents the mixing or the bruising and during the transportation, and uh, it reduces the vibration and the mechanical shock to the food product. And its other function is to protect the main function. So it protects basically the food product from the contamination or any chemical or microbial contamination, and also from the oxygen and the moisture and from the different dirt. Also, it protects the food material. And then it is then it is also like convenient if we are putting something in the packaging material. So it's easy to open and we can we can easily handle the food product. And then packaging can also be used as a medium for the communication. So uh, the nutrition value or the price or the product shelf life and in which condition it should be stored, and what are the different product ingredients are used. All these can be conveyed using the packaging materials. So there are these different packaging materials for the food product. These are the sacks, these are the cartons, these are the pallets. So this is the mesh, these are the plastic, these are the containers, and this is a cardboard container. So there are like different kind of packaging materials can be used, and also the different kind of packaging levels like the uh, like putting into the bulk or the single product packaging. So there can be these different packagings can be used. So these packaging material, they are basically must be non-toxic and compatible to prevent the contamination and maintain the food quality. So the assertion is true, and it should be having sufficient resistance to tamper. So it should resist to alter the packaging or the tampering of the packaging, and it should be easy to open and dispose of. So the reason is also correct, because reason is true as these are the essential attributes for consumer safety and convenience. And also this should be low cost, this packaging material should be low cost and adhere to the standards in the shape, size and weight limitations, provide the protection against the moisture, air and light to the commodity, and it should be appealing in appearance, and printability should be there on the packaging material, and it should be recyclable and biodegradable. So that basically all these are important essential attributes for the packaging material for its safety and convenience of the carrying of the food material. So, but the reason is actually not the direct explanation of the assertion of why the packaging must be non-toxic and compatible with the produce. It supports other packaging requirements, not the specific one stated in the assertion. So both are true, but not a reason is not explaining correctly the assertion. Okay, so we have the different containers in the packaging, which is primary level, secondary level, and tertiary level. And what is, we have the different statements regarding that, and which is a true statement regarding type of container. So the primary container is the first line of defense between the product and the environment. The tertiary containers are used to group products for transportation and warehouse storage, and tertiary containers cannot protect shipments during transit. So we need to tell which statements are true. Okay, let's see that the primary containers, they are basically the first line of defense between the produce and the environment. So the primary containers, they directly surrounds the product and protect it from the environment. So this is basically the primary packaging. If we talk about, this is also primary packaging. So this is in the can, peas in the green peas in the can, and in the plastic directly into the contact with the container. The second container, secondary container is the outer box or the wrap or the drum to hold all the units together, providing an overall protection. So when we are putting the single units together into a carton or something, so that is a secondary container. The tertiary container is basically grouping of the products for bulk handling, warehouse storage, transportation, and shipping. And the main goal of the tertiary packaging is to properly protect shipments during transit or transportation. So first primary packaging is like one piece, then secondary is the case, and third is the bigger, tertiary is the bigger pallets. So here statement one is true that the primary container is the first line of defense between the product and the environment. And also the second statement is correct that the tertiary containers, they are used to group products for the transportation and warehouse. Whereas the third statement is incorrect that the tertiary containers cannot, whereas it can protect shipment during the transit. Okay, let's discuss this question now. That a fruit vendor is planning to transport a bulk quantity of tomatoes from farm to local market. He decides to use sacks, combine them with baskets during transit. Which material are commonly used for making sacks for produce transportation? So these sacks are basically made from which materials? So the answer, correct answer is cotton, jute, plastic, plastic in plastic, HDPE, and PP. So this is basically the cotton sack. This is the jute sack, and this is the plastic sack. So the sack are typically made from the cotton, jute, plastics like HDPE, PP for the durability and flexibility. They are usually combined with bamboo baskets and the wooden boxes to improve the cushioning and reduce the bruising, injuries, and losses during the transportation. So the merit is that it is low cost, high strength, reusable, and require less space for empties. And demerit is that low protection against the puncture and the compression and the vibration and impacts. So also these are poor in stackability. So here answer D is correct. Okay, the sacks often combined with bamboo basket or wooden boxes in order to, for which purpose sacks are often included with bamboo baskets and wooden boxes. Okay, so to reduce basically bruise, injuries, and losses during the transportation. So the sacks, they typically are made from cotton, jute, or the plastics like HDPE, PP for the durability and flexibility. But these sacks are combined with usually these kind of bamboo baskets or the wooden boxes, to improve or to provide the cushioning effect and minimizing the mechanical damage to the delicate produced during the transportation. Okay, so next question is about the intelligent packaging system. So the assertion is saying that this intelligent packaging system are only used for labeling the food with expiry dates. Reason is saying that these systems do not perform any sensing, detection, or communication function. So we need to tell if the assertion is correct or the reason is correct or not, and if reason is correctly explaining the assertion or not. Okay, so basically both assertion and reason are incorrect here. So basically in these intelligent packaging systems use communication function to facilitate decision making aimed at preserving food quality, extending the shelf life, and improving the overall food safety. It is capable of carrying out intelligent functions such as the sensing, detection, and tracing, recording, and communicating certain type of information. So they perform basically these functions, and they are not only used for such purposes, but this is the additional function of that. They use the labeling of the food and tell the expiry dates. So these basically intelligent packaging, they are integrated with the biosensors basically, and which will going to monitor the food condition during the storage and transportation. Like it can have pH sensors, which detect the pH change in the packing of the meat and the fish. And they can have the ethylene sensors also, which can monitor the ripeness of the fruits and vegetables. So these biosensors basically detect these volatile organic compounds released during this when the food is getting spoiled. So it sends and it will tell if the food is in the good condition or not. So this intelligent packaging system, they are not just limited to labeling, but they provide the advanced features like the sensing, detection, tracing, recording, and communicating. So both the assertion and the reason are incorrect. So this intelligent packaging, they have the indicators like the freshness indicator, microbial spoilage indicator, gases change indicator, or the time temperature indicator, or the thermal and abuse indicators, and then they have the sensors, like the biosensors, electrical nozzles and the tongues, and then they have the data carriers like the RFID labels or the barcodes and the QR codes, which are going to help in the function of sensing and detecting the shelf life of the food products. So here is one example of one kind of sensor. So this is the peach color of the basically in the sensor when the oxygen is not there in the packaging material. So when the oxygen is supplied to this, so it will convert into the blue color. So when so this sensor is basically changing the color from pink from peach to pink to gray to blue based on how much is the oxygen concentration is there. Then there are these sensors, which is amine gas sensors. So when the food is spoiled, there are different amines they are produced in the food, and that can be sensed using sensors and can be analyzed if the food is spoiled or not. So this is the guava basically, which is packaged basically, and this is the basically sensor is put, and if it's spoiling, the color is getting changed. Okay, so this is the last question for today. So which of the following statements is correct about corrugated fiber boards? So the raw material for CFB is mainly the kraft paper. However, agave bagasse byproduct from the textile industry has also been used, and it consists of two or more kraft paper liners and layers of corrugated material, which are the fluid, sandwiched between the flat layers or the liners to provide the cushioning effect and abrasion resistance. The third statement is that the fluid material is developed using corrugator, which involves passage of flat kraft paper between the two serrated rollers, followed by application of the adhesive to the tip of the corrugations, and the liners is stuck to the corrugated material under pressure. Fourth statement is that the primary purpose of the corrugated fiber board is to provide the aesthetic value to the packaging. So we need to tell which statement is correct regarding CFBs. Okay, let's see. So statement 1, 2, and 3 are correct here. So the raw material for CFB is basically the kraft paper only. However, agave bagasse byproduct from the tequila industry has also been used. So this is correct statement. So it consists basically in cardboard. There are different layers, and in between there can be this cushioning material. So it consists of two or more layers of the flat kraft paper. So this is called, this flat kraft paper are liners. So there can be layers of this liners, and then the layers of corrugated material or the fluid will be there. So this is fluid will be there, sandwiched between the two flat layers to provide the cushioning effect and the abrasion resistance. So like this, uh, this is liner, this is liner, and in between there will be fluid to provide cushioning effect, which is true. So from here, one liner will come. So that will go through the this basically this uh, particular this roller, and it will take the shape of the fluid. And here from the pressure roll, this liner will be there, and one uh, from here some kind of the sticky material or some kind of the adhesion material will be provided, and because of the pressure here between these two rollers, so this will stick. So this will be liner, and it will stick, this fluid will be stick on that. So the fluid material is developed using corrugator. So this is basically the corrugator. Based on, because of this corrugator, this fluid material developed, and which involves basically passage of this flat kraft paper between the two serrated rolls. So these are the two serrated rolls, and this liner will come and it will take the shape of the fluid. Then followed by the application of the adhesion to the tips of the corrugation, and liner is stuck to the corrugated material under pressure. So here basically adhesion material will be put, and this will be the liner when the pressure will be applied, and they will be stick this liner and this fluid. The primary purpose of this corrugated fiber board is not to provide the aesthetic value, but to provide the cushioning effect and the abrasion resistance. So statement 1, 3, 2 and 3 are correct, and 4 is not correct. Okay, so topics we discussed today are basically involved the cleaning and the washing of the fruits we discussed, of the spices and condiments also we discussed, and then we discussed about how the different like the sifters or different equipments can be used, like the destoners, it can be used for the cleaning purpose also. Then sorting and grading we discussed, how the sorting and the sizing and the grading can be done, and the new methods like the roller graders can be used, and the new innovations like computer based or the AI based grading systems, we discussed about them. And then we discussed about some numericals based on the energy, like size reduction, the cleaning systems efficiency. And then we discussed about peeling. And then we discussed also about the dicing. And then we discussed about the different packaging materials and the different containers in which the food product is being packaged. And then we discussed about different packaging methods. and like how the CFVs are formed, and what are the different uh, secondary and tertiary containers we can use in the packaging, and what are the different things we should keep in mind when we are selecting any packaging material. We discussed all these things today, and in the next class, we'll be discussing about the minimal processing, hurdle technology, intermediate and high moisture fruit products, and the cut fruits and vegetables. So this is the basically this first one is my YouTube channel link, where I'll be uploading the recorded video for this week 4. And the second one is the Google Drive link, where you can visit and you can find out the PPT of the today's lecture. And you can put your questions on this Q&A for discussion forum. And I will request you guys to kindly join the live interaction sessions and ask your doubts also. And you can be like solving questions with me, and you can also like participate in question solving. And also it would be good for you, because all the like if you will take all the lectures at once, it will be very difficult, or is a bulk material to uh, study at one time. So you should, because you can get questions from my study materials, what we are discussing in the tutorial classes. So you can get some questions in the main exam from here. So you must study all these lecture videos. So it will be better if you take the live interaction session, as uh, you can cope with the, or you can be on time with the whatever we are covering, all the study materials or all the lecture videos. So thank you so much, everyone. Next session will be on next Sunday, 4 to 6. So also kindly submit your assignments on time. And if so there is this my YouTube channel. So I have this YouTube channel, and if you can see, so if you see here on my, so this in this playlist, if you see, so this is the course for this post-harvest operations and processing of fruits and vegetables. So let me, yeah, so I was telling, yeah, this is a full playlist. I wanted to show you something. So in this, if you go, I think, yeah, so view channel. Yeah, so in my playlist, if we go, so this is a few full playlist. So this is basically the course which is having 6 lecture videos, and I'm including the like here the previous year also I have taken the same course. So till now I have provided you the 3 week lecture videos or the live interaction session which I took with the previous year students. So it is also there here for all these three live interaction session, and these three are the new one this year's live interaction sessions this July 2026, and these three are for July 2025. So you can watch all these lecture videos also. It will be gonna help you to solve your assignments also, and some questions you may get from this in the exams also. Uh, so also I have a request that please uh, go through all these videos on time. And thank you so much for taking my classes. And I have a request to submit your feedback also. So when you get the link for the feedback submission, please submit your feedback so I can improve on my teaching skills. And if you are not, if you are like liking my teaching style, or if you are not liking, you can put into the feedback form. Okay, thank you everyone. This is the end of today's session. Let's meet next Sunday.